It is nothing to do with your levels. It is completely a new ball game. You are watching the motion. Is this passenger moving or at rest? Velocity of A relative to B. The frame you are living as frame of reference. Thinking beyond what we observe. This is a subject completely different from theoretical subjects. For vectors, you must write the final answer with the direction because you get marks for that. Good evening, everyone. So after another 1 week, after the results, and we are meeting here with another big topic of relative motion. Relative motion. Now, the thing is, even though I said that we are going to start this relative motion concept, the relative motion, now as a physicist, I really don't like to tell that we are doing relative motion. You know why? This relative motion, what we are doing here is not exactly the relative motion what the world of physics talking about. And I like to disappoint you at the very beginning. This is relativity before 1905. Before that, we call it classical relativity or Galilean relativity. Classical relativity or Galilean relativity. So this Galilean relativity or the classical relativity is about what you see around. And then Einstein in 1905 introduced the special theory of relativity, what we are not touching here at the moment, but I like to discuss it. And I was thinking about this because just give me like couple of weeks until end of July till 2026 batch people goes. Then we are going to do something very serious, that is quantum physics. Special theory of relativity, general theory of relativity. General theory of relativity invented in 1915, again by Einstein. So general theory and special theory we are not discussing here, we are learning classical theory of relativity. That is Galilean relativity before 1905. Okay, that's the beginning of the approach. Very small topic, but giving a big understanding. And coming to the exam, popular questions, not very regular questions coming, but very important topic. So after results, everyone, welcome to advanced level officially. Now we all are officially in advanced level. Unfortunately, couple of students in all groups together, less than 5 people, but have left the stream, which is not very pleasant to hear. We all want you all to do science, but because of the results, sometimes we may make decisions a little bit differently based on your results. But anyway, I have a small advice for you all. It is nothing to do with your levels. It is completely a new ball game. If you have bare minimum results to do A levels, start immediately. Start immediately. Do science. Don't worry. This is a very good starting point. That is relative motion. Yes. We'll take a good example. I keep this, the empty background for you to think better. Let me give you a small example. Now, we'll do some small activities as well. One, the very first thing, you think about a situation where you get into a bus, public transportation, bus or a train. I hope everyone here in this class, online, you have at least traveled once in your lifetime in a public transport, bus or a train. Why I said that? Last week, I got like a horrible experience. There were few students who had never traveled in public transport. They are posh people, rich people. Right? But to get this experience I'm talking about, you have to travel in the public transport, trains and all. Yes, what we used to travel to school, not from the private vehicles all the time. Yes, so now, when you get into a public transport, you get a double seat. There was a passenger next to you. Imagine, because I would have showed this in a video, but I really want you to imagine. So you think about a passenger next to you sitting. You also get a double seat and you sit and observe the passenger. What are you going to observe the passenger? No, not the features and the figure. You are going to observe the motion. You are watching the motion. Is this passenger moving or at rest? I need good answers here. I'm waiting for the answers here. Is that passenger moving or at rest? Is that passenger next to you in the train or the bus moving or at rest? I'm asking about your observation. Gitme had given a good answer. Farhad different answer. Navitu completely different answer. Sania saying it different. Janisha another answer. Yeah. Navinu there. Sashinya there. Umar, yes. Sanjeewa Vijay Singha is giving different answer. Rachel is like a completely comprehensive explanation. From the viewpoint of myself, they are stationary, but the external viewpoint, they are moving. I think he is moving since when there is a break. Nice, good on. Kumutu is telling something else. Sitika is giving a good answer. And some people did not answer at all yet, especially Sit and Shakya did not give any answers yet. Asitika gave answers now. Bus is moving and the passenger is at rest. Uttum did not give any answer as always. Uttum, I need quick answers. Uttum namakiyanakal answers then. Hurry up. Vihanga. Right. Shakya. Yes. Joining. Right. Pritasha. Did I miss your answers? Fatima is giving answers now. Risara, did you answer? I'm checking everyone's connecting to this discussion. Yes. Okay. Medini gave the answer right now. Okay. Yes. Good idea. I like your thoughts. Yes, the passenger is not moving as you observe. Yes, clear. I like the answer. At rest. Because what I ask is, what do you see? As you observe, is the passenger moving or is passenger at rest? That was my question for you. That was my question for you. Okay? If passenger is not moving according to you as you observe, we call that the frame you are living as frame of reference. We call it frame of reference. Right? Now, you are observing the passenger next to you and one of your friend outside the bus, standing in the bus stand, looking at the same passenger. Very interesting passenger. So, you also observing the passenger, your friend is also observing the same passenger. Now bus is moving. So, your friend observed that the passenger is moving with the motion of the bus. So, this is the idea I'm talking about, that the Galilean relativity, classical relativity. So, when you are living in a frame, you sometimes the object in the same frame cannot be observed as objects which are moving. So, when it is moving, the object, the passenger, not it, objects moving or the frame moving, the passenger and you both moving at the same speed, same velocity, same direction. So then you do not see any motion of the passenger. But whoever outside the bus observing the same passenger. So the outside person is in a different frame of reference. So the passenger, the friend outside the bus, observing the passenger moving as the speed of the bus. Hope you understand that. So this is the concept of classical relativity, right? And we'll take another example. Okay, I'm going to take another example. Yes, we are going to talk about something here. Right. So I think we need a little bit of a good background. Yes. Now look at this bottle. Look at this bottle. This bottle. Look at this bottle. Now tell me, is this bottle moving or at rest? Is this bottle moving or at rest? What do you think? Is this bottle moving or at rest? Your opinion. Checking your work, your answers. Is it moving or at rest? I need everyone's answer. And physical class students who missed the lesson and joining, and people who are joining newly after results, everyone try to comment and send the message, and we see the messages, we can read them and see, is this bottle, and this bottle advertisement, okay? What is the brand? We can charge something. Clear water, okay? In the bottle advertisement, clear water company will sponsor this. What do you think? Is it moving or at rest? Interesting question. I see this as at rest. I see this as at rest. Even though I see this as at rest, the important thing is I can't conclude, as this bottle is not moving or at rest, just looking at it. Now that is kind of a difference. That's kind of a difference between observation and the perspective. Now tell me, is this bottle moving or at rest? So we need to think a bit about that, what you see. Now just think like this. Yes, I understand. This bottle is not moving on this table. When you look at this table, so it is completely at the same place. All the measurement to the bottom of the bottle on the table is the same, no difference. And this table is inside our studio, CCG online.lk, CCG online Mahagedara studio, right? And here this is at the same place of the studio. Yeah, in the studio. Not on the road. Huh? So there's a green screen road. And no, the bike is not coming and hitting us. And if we think about the position of this online Mahagedara, it is at the same place all the time. Even last week when I was coming here, it was at the same place. You check the Google map, it is at the same place. It is not changing the position. Next week when you're coming, it is here, the same place at the same time. No problem. It's at the same place. Confident. Now we have a problem. In the maps, on the maps, online Mahagedara is at the same place, but is this position of the map is it at the same place in the space? That is what you call thinking beyond what we observe, the developing the perspective, developing a vision about this. What happened? Earth rotates. Earth rotates. When Earth rotates, this position will never be at the same place. And when the Earth rotates and revolves around the center of the solar system or the sun, and the solar system rotates and revolves around the center of the Milky Way, and the Milky Way rotates. I mean, I'm talking very superficial idea of the motions of the space objects and the galaxies. Superficial idea. So the Milky Way rotates and revolves around the center of the universe. In that case, universe expands and contracts. A few billion years maybe, doesn't matter. There are numerous motions. So how the hell this bottle remain at rest? That is what we have to think and see as physicists. You understand? Right? If you're talking about absolute rest position, that will be only the center of the universe. I mean, we don't know where. We don't know where it will be the center of the universe. Right? So this bottle, absolute sense, this bottle is not at rest. So then can we talk about rest position of the bottle? Yes, based on the observation. What is the base of the observation? We usually tell, like even in textbooks when you're reading, a bottle is at rest on the table. Oh, sometimes in simple terms, say a bottle is kept on a table. Without seriously emphasizing that, touching the concept of frame of reference and tell us what the table is, the frame of reference. What's the frame of reference? Frame of reference is the frame, non-accelerating frame we can study a motion of an object relative to the frame on Earth, assuming the total assumption, the biggest assumption, the Galilean relativity, classical relativity conceptually, it says, but this is at rest relative to the frame of reference, assuming that Earth is not moving at all. Okay, right. Let's go to the next part of it. So this bottle, absolute sense, this bottle is not at rest. So you all have this note with you in the book. So please read it through until we give you the PDF for something for newcomers, right? Okay. So consider two cars, A and B, which are moving to the same direction at velocity 60 kilometers per hour and 50 kilometers per hour. So there are two cars. Now my question is, in 1 hour, where this, the blue color will be, how far this blue color will be? The blue color will be 60 kilometers from the starting point. 60 kilometers. And the orange color car, right? So let's go to this. Orange color car, this one, right, will be 50 kilometers away from the starting point. And my question is, what will be the difference of the distance between A and B after 1 hour? After 1 hour, what will be the difference? Ah, nice. People answering very well. Already, Sanjeewa Vijay Singh, yes, already told answers. Others, 10 kilometers, very good. 10 kilometers. So how did you get this 10? So what if it is VA and VB? What do? You subtract this like 60 minus 50. You subtracted 50 from 60. And we can do the same thing here. We can do the same thing here. We can subtract VB from VA. VB from VA. So we have good names for them as well. What are the names? Velocity of A relative to B. Velocity of A relative to B, that is called as VAB. Velocity of B relative to E, that is VBE. Right, people. Read it through. And E is the earthly observers. Nice work. Okay. And ask all the questions, because we are going to go for questions. If you don't have questions, I am going to ask questions. Right, people, let's do this. Here is the question, and please send the answers as soon as possible. And it is a nice evaluation as always. So people have the book, so please do it on the book itself from pen. It's good that Janisha has sent some answers. Rasika Silva is asking, sir, if all the motion stops suddenly with break, would the bottle be thrown away? Yes, correct. Janisha, so I like you putting the directions very clearly, and I like you mentioning the directions of the final answer also in the answer. Writing the equations at the beginning of the work. That is really important. The car is coming. So you need to write the equations. The key is writing the equation. The equation nicely. Okay, let's go through the discussion. A is 60. B is 50. And now you can subtract it easily. And I have given 3 marks. Let me tell you what you get here these 3 marks for. So let me give you the 3 marks here clearly, okay? So number 1, for your direction 1 mark, the magnitude 1 mark, and unit 1 mark. So those are the 3 parts I am focusing on. So either you have to write the direction at least in words. So people who got 5 out of 5, raise the hand. The direction was compulsory. That's fine, that's fine. That's why we are doing it. Don't worry. Just put the next question. You can, direction is compulsory for always for vectors. You have to mark. Sehansa, how much? Now can you see that? Now this is the process here. Now you all know the process here. Now you have to be honest. You work, you mark, you communicate with the teacher, and you evaluate yourself. That is to be done throughout 2 years. This is a subject completely different from theoretical subjects. You need to develop your communication. Communication is not always talking. Communication with the examiner. When you write sentence, now some of you say, sir, I did not know that. I supposed to write the equation. Now you know. So I did not know that we have to write the unit. You must write the unit for every single question in advanced level for next 2 years, every time as the final answers. As the final answers. 3. So I did not know that direction to be marked. Always, every time for next 2 years, when you're planning to do it for what? For vectors, you must write the final answer with the direction because you get marked for that. Even they don't give marks, that's up to them. That's their job. You don't have to predict it. You don't have to predict it. You don't have to worry about it. You just write the direction. If they give the mark, you get the mark. Sometimes they will not give. I don't know. I know definitely if you write these 3 parts, you get the full marks. There are some, random years, they may not consider the direction. They may not consider the unit. Those are very random scenarios. Sometimes, not consider the direction means like they give 1 mark for all 3. Right? So there are some loose marking schemes, random scenarios, but focusing mainly for that. We write all 3. If it is a vector, we have to write 3 things. If it is a scalar, we only write 2 things, that is magnitude and the unit. That's it. Okay. Let's go to the next part. Part B. Right. So let's do this one. Now imagine the condition. Very important condition. You are going to imagine. Okay. Now think you are in this particular car. You are in this particular car. Which one? Now you are in the car in the front. You are in the car in the front. Okay. You are in the car in the front. So when you are in the car in the front, you are driving and you see from the side mirrors or the front, the back mirror, right? So you see A is coming towards you. So you are in car B. Imagine, I can do an animation, I can give you a video, but this is all about the imagination because even Einstein started imagining this while he was traveling in a train. The special theory and the general theory of relativity concepts. Right? So, you imagine there is a car coming behind, it is faster than yours. You are driving car B in front slowly. So what do you see? What do you see? From the mirror, you see that this is getting closer to you. So in simple terms, if you are in B, you see that what? A is coming towards you at 10. A is coming towards you at 10. That is the 10 we were talking about. That is the 10 to the right. Velocity of A relative to B, velocity of A relative to B is 10 to the right. So on the other hand, you are in this car. You are in this. So relative to A, car A, relative to car A, B is coming backwards. So you see that this is coming backwards. That is that arrow we marked to the backward direction here. Here it is. You mark this arrow backward because to explain B is coming backwards. Now what I was talking about, first of all, think that you are in this car. You are in this car. You are in this car, you are going at 50. And meanwhile, there is a car, the blue color car coming towards you. The blue color car coming towards you. Okay? Now, since 50 kilometers per hour, this one is going slightly slower speed and this one is getting closer to it at 10. Understood? So, you are driving and you are looking through the mirrors, you can see the one behind coming closer to you fast. You are looking through the mirror, you can see that it is getting close. Imagine the condition. Oh, today or tomorrow when you're going out, check this. Check this. Observe. And I like to add, like, very important part. Now, we have seen this, right? We have seen this every day, every time when you are in a vehicle. But we did not understand what is this principle and how these numbers are there. I mean, this is not, condemning or insulting for any of the streams, but honestly, you understand this knowledge you get about the environment is only for physics students. Even you're doing arts or commerce or anything, you will not get this, the comprehensive picture of the surrounding world. So that's why I usually always tell you, if you know physics, if you know basic physics, you don't have to get A for physics. You understand the world around you. You understand the world around, the behavior of the world around you. That is serious. Okay. And on the other hand, now you are going to this car. You are in this car. When you are in this car, what happened? Now you see this one coming behind, coming backward, like reversing. You are driving a faster car. You see that you are getting closer to the car in front, or you see that the car is getting closer to you. So backward. So that is what this arrowhead is all about. Is that clear? Right? Any doubts? Now you can ask, and let's go to the question. I gave the interpretation, and now we can go to the next question part, motion to the opposite direction part.